Sound vibrations may be generated by many different sources. Whether they originate in the orifice of a modern jet engine or the throat of a 400-year-old tortoise calling its mate, or an electrical buzzer, the vibrations have essentially the same effect. They fluctuate the pressure of the atmosphere on our eardrums, causing them to move rapidly back and forth. This pressure variation is measured in terms of a unit called a microbar, which is 1 dime per square centimeter. We can decrease the pressure variation and thereby make the sound less intense by decreasing the amplitude of the source's vibrations. Listen as we decrease the power of the buzzer. If we increase the power, the sound intensity will increase. What we are doing is varying the amount of sound energy which stimulates your ear each instant. This can be accomplished another way, too, by varying the distance the pressure waves have to travel to your ear. If we move our microphone away from the source, the intensity will decrease. If we move our microphone closer to the source so that the energy has less distance to travel to your ear, the intensity will increase. Intensity may also vary according to the characteristics of the room in which you are listening. If we play a pure tone of constant intensity, you can, by moving your head slightly to the right and left, make the sound seem less or more intense. Try it. This phenomenon occurs because sound waves that have been reflected from the walls interfere with sound waves that are coming from the loudspeaker. They combine to produce pressure waves that seem to stand still, thus forming areas of high and low intensity in the room. However, ideally, in free space where there are no reflecting walls, the energy at your ear will vary inversely as the square of your ear's distance from the sound source. Listen. I am now speaking to you from a distance of 1 foot from the microphone. I am now speaking to you from a distance of 3 feet from the microphone. You see, by making a sound travel 3 times as far, we have decreased its intensity to about 1/9. Listen again. I am now 1 foot from the microphone. I am now 3 feet from the microphone. To sum up, the intensity of a sound depends chiefly on the energy of the source and its distance from your ear. Thus, intensity may be measured in energy units, ergs per square centimeter, or converting to power units, in watts per square centimeter. For most purposes, however, it is more useful to measure the intensity of sound on a comparative scale. It's customary to express this relative intensity in a unit of measure called a bell, B-E-L. Bell, named after Alexander Graham Bell. Listen to these 2 sounds. They have an intensity difference of 1/10 of a bell, 1 decibel. As you heard, a difference of 1 decibel is so small as to be barely perceptible. If one tone has 1/4 the power, that's 1/2 the sound pressure of another, it is said to be 6 decibels less intense. If one tone has 1/16 the power, or 1/4 the sound pressure of another, it is said to be 12 decibels lower. If one tone has 1/100th the power, or 1/10 the sound pressure of another, it is said to be 20 decibels less intense. As you can see, the decibel scale is logarithmic, and the decibel expresses a relative quantity, the ratio between two acoustic powers. When it is desired to express the intensity of only one sound, a scale is used in which the reference intensity for 0 decibels is 10 to the minus 16 watts per square centimeter. A person with very good hearing in an extremely quiet location can just barely hear a 1,000 cycle tone at this 0 level of intensity. The corresponding pressure variation is only about 0.0002 dynes per square centimeter. That's less than 1/1000th normal atmospheric pressure. You see, then, your ear is extremely sensitive. So that you can become familiar with the decibel scale, listen as we vary the intensity of my voice. Now I am speaking to you in a voice with an intensity about 6 decibels lower than normal. Now my voice has an intensity level about 10 decibels lower than normal conversation. 20 decibels less intensity sounds like this. 30 decibels less intensity sounds like this.